In this lesson, we'll be solving some examples on limit of trigonometric functions. There are core trig limits identities that we need to consider, and one of them is that the limit as x approaches 0 of sine x all over x is equal 1. This is one of them. Let's consider an example to evaluate the limit as x approaches 0 of sine 3x all over x. What will be the answer? Now you can solve this by applying the standard form, right? So we can have the limit as x approaches 0 of sine x all over x multiply 3, right? And we know that the limit of sine x all over x is equal 1. So what we have will be 1 multiplied 3, which is equal 3, the final answer. Let's take another core trig limits identities, which is that the limit as x approaches 0 of 1 minus cos x all over x is equal 0. And this can be derived. How is it 0? Let's confirm by applying the trig identity of 1 minus cos x equal to sine square x over 2. If we replace the value of 1 minus cos x with this in that expression, it will imply that the limit as x approaches 0 of 2 sine square x over 2 all over x. And we know that if we have sine square x is the same thing as sine x multiply sine x. So we apply that here. Let's separate the coefficient 2. So we are going to have 2 multiply the limit as x approaches 0 of sine x over 2 all over x multiply sine x over 2. So the first part, our goal now is to convert it to standard form. And to do that, let's look at the coefficient of the top. Alright, the coefficient here of x here is 1 over 2. So we can multiply both sides with the coefficient so that they can be even. They can be in the standard form. So we are going to have the limit. Now it is 2 multiply the limit. 2 multiply the limit. So this will give us 2 multiply the limit as x approaches 0 of sine x over 2 multiply 1 over 2 all over x multiply 1 over 2 will give us x over 2. And we can see now that this is in standard form now. Only this is in standard form. We have 1 over 2 left. So this multiply sine x over 2. Okay, now sine x over 2 all over x over 2 is 1. The limit of this is 1, so we are going to have 2 multiply 1. 1 multiply 1 over 2 will give us 1 over 2. Multiply the limit As x approaches 0 of sine x over 2, we replace x with 0, so we are going to have 0 over 2, which is 0, right? Uh, so we are going to have multiply 0. So 2 multiply 1 over 2, which is 1, multiply 0 is 0. So we have established that the limit as x approaches 0 of 1 minus cos x all over x is 0. Let's take the next identity, and this is where students often make mistakes. Let's see the limit as x approaches 0 of 1 minus cos x all over x squared is equal. Now student would think this is 0 as well because the difference is just x squared, but the answer here is 1 over 2, and we are going to be deriving this, and you see how we got 1 over 2. Now let's do the same thing. Let's replace the value of cos 1 over cos 1 minus cos x. Let's do the same thing here. We know that 1 minus cos x is 1 minus cos x is the same thing as 2 sine square x over 2. Alright, so let's replace this in that expression, and that will imply that the limit as x approaches 0 of 2 sine square x over 2 all over x squared. Now this would give us, we know that if we have sine square all over x squared can as well be written as sine x all over x all squared, right? All squared. We can do the same thing here. So this will give us the limit as x approaches 0 of 2 multiply, now we can have sine x over 2, right? All over x, everything squared. Okay, if we have this, all we have to do now is to convert the inner part to the standard form, and to do that we take the coefficient of the top here and multiply it both sides with it. So we are going to have the limit as x approaches 0 of 2 multiply sine x over 2 multiply 1 over 2 all over x multiply 1 over 2 will give us x over 2. So all squared. Okay, we can separate the constant now. So we are going to have 2 multiply the limit as x approaches 0 of what we have left now is sine x over 2 all over x over 2, and we know that this is 1. This alone is 1. The limit of this is 1. Multiply 1 over 2, everything squared, right? Okay, so let's rewrite this. We are therefore going to have that the limit, so we have that the limit 2 multiply the limit as x approaches 0 of sine x over 2 is 1. So we are going to have 2 multiply 1 over 2 will give us 1 over 2 squared, and this will give us 2 multiply 1 over 4, right? And 2 multiply 1 over 4 will give us 1 over 2. So we see that identity is correct. Let's take the one more example, and one core identity. Now, the limit as x approaches 0 of tan x all over x is equal 1. So this is one of them that needs to be known. All right, and we can derive this. Let's see if this is correct. We know from the trig identity that tan x is the same thing as sin x all over cos x. And if we replace this with tan x in the expression, we are going to have that the limit as x approaches 0 of sin x now all over cos x, or divide by, okay, I can have divide by, or I can have it as multiply 1 over x. It's the same thing, right? Or divide by x is the same as multiply 1 all over x. So that what we will have will be the limit as x approaches 0 of sin x all over x multiply cos x. Okay, the next thing we want to do is to rewrite this in the standard form, and once we are able to achieve that, we have solved the problem. So we can have the limit as x approaches 0 of sin x all over x. So we are just separating what we have here. Multiply, we have 1 over cos x left, 1 all over cos x. And the limit of sin x all over x is 1. Multiply, so we are going to have 1. The limit as x approaches 0 of cos x will be 1 all over cos 0, and cos 0 is 1. So we have 1 all over 1 will give us 1. So the answer is 1. So we'll see how we derived this. Let's take a final example before we, okay, let's take two more examples. You are given to evaluate the limit as x approaches 0 of 1 minus cos 3x all over x squared. You may pause the video before watching the solution just to try your hands on it. So this will give us, we already know that cos 1 minus cos 3x can be written as 1 minus cos 3x is the same thing as 2 sine square. Instead of x now is 3x all over 2, right? So let's replace that in that expression. So we are going to have the limit as x approaches 0 of 2 sine square 3x all over 2, everything divided by x squared. Now let's simplify that further. We are going to have This will give us, let's separate the constant there to multiply the limit as x approaches 0 of sine square x. Remember that sine square 3x over 2 means sine 3x over 2 multiply sine 3x over 2. So we can rewrite that to have sine 3x over 2 all over x, everything squared, and this will give us 2 multiply the limit as x approaches 0 of, we want to rewrite this to the standard form so that we can have in the denominator 3x over 2, and to do that we just multiply both sides with the coefficient of x here, and the coefficient is 3x over 2. So we are going to have sine 3x over 2 multiply 3x over 2, right? All over x multiply 3x over 2, right? X multiply 3 over 2, sorry, will give us 3x over 2, 3x over 2, all squared. And we know the limit of 3x over 2 all over 3x over 2 is 1. So we are going to have 2 multiply 1 multiply 3 over 2, we have 3 over 2 left squared, and this will give us 2 multiply 3 square is 9, all over 2 square is 4, and this can cancel this to give us 9 over 2, which is the final answer. Let's take a one more example. As a matter of practice, so you can pause the video and try your hands on it before you watch the solution. Now, if you are given to evaluate the limit as x approaches 0 of tan 2x minus sine 2x all over x to the power of 3, how do you solve this? Now let's start by replacing tan x with a core identity, right? We know that tan 2x is the same thing as sine 2x all over cos 2x. So let's replace that. We are going to have the limit as x approaches 0 of, now we have sine 2x all over cos 2x minus sine 2x, right? Everything all over x raised to the power of 3. Now for the top part, all right, we have fractions there, and we have sine 2x common we can just factor out sine 2x so that we can have the limit as x approaches 0 of sine 2x multiply, let's have 1 all over cos 2x minus 1, because sine 2x multiply 1 will give us sine 2x, right? And the same thing here, and this is the same thing as all over 1. Everything all over x to the power of 3. Now, when you are adding fraction, you can find the common denominator, just like if you are having 1 over 2 plus 2 over 3, right? You get the common denominator, and here it is 6, right? 6 and 2 will give us 3. 3 multiply 1 will give us 3, right? The same thing, plus 6 and 3, 2. 2 multiply 2 will give us 4. At the end of the day, you are having 7 over 6. The same thing we want to apply here. Here, the common denominator, so we still have the limit as x approaches 0 of sine 2x. Alright, here the common denominator is cos 2x, right? We have cos 2x. Cos 2x divided cos 2x will give us 1, right? And 1 multiply 1 will give us 1, minus cos 2x divide 1 will give us cos 2x, multiply 1 will give us cos 2x. So we have cos 2x. So let's write that here. So we still have here 1 minus cos 2x all over cos 2x. Okay, we are gradually transforming this to the standard form. Everything all over x raised to the power 3. And if we rewrite this properly, right? If we rewrite this properly, what we are going to have is the limit as x approaches 0 of sine 2x multiply 1 minus cos 2x all over x cubed multiply cos 2x, right? So we can split this so that we can have all standard forms. So this will imply that the limit as x approaches 0 of sine 2x all over x, so this is the first part, multiply 1 minus cos 2x all over x squared, so that this multiply this, we already have x cubed. We have the second part, but we have 1 all over cos 2x left, so we are going to have 1 all over cos 2x. We have been able to get the standard forms, so we can go ahead now and evaluate each of the terms. So let's start with the first one. And the first one, we are going to have the limit as x approaches 0, as x approaches 0 of sine 2x all over x. So all we have to do is convert this to the proper standard form, and that will be it. We just multiply both sides with the coefficient of x here, which is 2 all over 2, so that we have in the end the limit as x approaches 0 of sine 2x all over 2x, right? Multiply 2, and this will give us 1, so that we have 1 multiply 2, right, which is equal to 2. So the first part, we are going to have 2 multiply. Let's see the second part where we have 1 minus cos 2x all over x squared. All right, if 2 is not here, all we'll have left will be 1 over 2, but because of this 2, so what we are going to do now, let u equal 2x, so that the limit as x approaches 0 of 1 minus cos u all over u square is equal 1 over 2. You still remember? But what we are looking for is this x all over x square. So let's rewrite this. Let's replace the value of u, so that we are going to have the limit as x approaches 0 of 1 minus cos 2x all over 2x squared. Okay, and to have this in standard form, you can see we have to replace this 2. All right, if you look at what we are looking for is this, right? So to make this in standard form, because the standard form is 1 minus cos x, right? Is 1 minus cos x all over x squared, that is 1 over 2. But here we are having 2. So to make this standard form, we just multiply the top with what is the coefficient here. The coefficient at the bottom is already 4 because 2x squared, sorry, is 4x squared. So 4 is the coefficient. So what we are going to do, let's multiply both sides. No, only the top with 4. So if we multiply only the top with 4, we are going to have, okay, now is going to be the limit as x approaches 0 of 1 minus cos 2x multiply 4 all over 2x squared, right? All over 2x squared. Now it is even now. This is now 1 over only the part, which is the limit as x approaches 0 of 1 minus cos 2x all over 2x squared is 1. So what we have left here now will be 1 multiply 4, which is equal 4, right? So this will give us 4. Which will give us 4. No, this is 1 over 2, all right? So what we are doing here, 1 minus the limit of 1 minus cos 2x all over 2x squared is 1 over 2. So we have 1 over 2 multiply 4, which is equal 2. So the second part is 2. And the third part, let's take the third part. The limit as x approaches 0 of 1 all over cos 2x imply as x approaches 0, we have 1 all over cos 2 multiply 0, which is the same thing as 1 all over cos 0. 2 multiply 0 is 0, so cos 0 is 1, so this is 1, and the third part is 1. 2 times 2 times 1 is 4, which is our final answer. Please subscribe to our channel, like and share.